In this video we are going to take a closer look at linear search. So linear search is the most basic type of search we can do on an array. And if we imagine that we have an array, let's call our array f, and let's imagine it contained 10 values with the indices from 0 all the way through to 9. And let's imagine the array was populated with some values and we want to search the array for a particular value. In other words, check to see if a particular value is in the array. So in this case, our search key, or the value that we're looking for, which we'll call x, is equal to 67. And if we look in the array, we can see that there are actually two occurrences of 67. One at position or index 3 and another one at index 5. So we can see by just looking at the array that 67 actually does exist in the array. We may not know the contents of the array, so it would be better if we wrote a search routine to do that. So the first thing that we're going to do is, well, we'll need to declare an array. So number one, we need to declare an array. And we'll call our array f as it is there in the diagram. The next thing we might want to do, we might want to print the array. Okay, so just to verify that all the values are there, we'll print it. And then the next thing we want to do is search the array. And of course we're going to use a linear search to do that. So search array for key. In other words, the value we're searching for, and that's stored in x. Okay, so in order to search the array, because this array is small, it wouldn't be too infeasible to actually just check every single value by saying, you know, if f0 is equal to x, or f1 equal to x, and so on and so on. However, that's not going to work for bigger arrays. Obviously, it wouldn't be too much work to do it for 10 values, but imagine if the array contained 1,000,000 values. That's not possible, so we can't do this. Okay, so if we can't access or try and do it manually, in other words, check every element of the array manually ourselves, what do we need to do? Well, the way we're going to do it is we're going to write, of course, a loop. So we're going to need a loop to do this. And the template that we're going to use is for, and we usually say int. Let's use I as our loop counter variable, equal to 0. And then we'll say I is less than f dot, and we can get the size of f by saying f dot length, and then we have another part over here where we increment I plus plus. And then inside the loop we can process the array. So we do something in here, process f I, and then of course we end the loop with a bracket. Okay, so let's break this loop down into its various different bits. So first of all, you can see we have this part here in yellow, and that is where we initialize our loop counter variable. In the middle, which we'll outline in green, so this bit over here in the middle, well, that's where we have the loop guard. And the last bit, which we'll outline in red, this is where we ensure that we make progress, or we step the loop counter variable along by 1 in order to visit each element of the array. So going back up to our array up here, what's going to happen is we'll use a loop counter variable I, and I will equal 0 at the beginning. So I is essentially pointing to this first element. The guard on the loop, I less than f dot length, ensures that I doesn't go past the end of the array. So at the end, I will be less than n. This guard keeps I less than n, and it stops it from jumping past n. When it does, of course, the loop is finished and we stop. And then this final bit in red is obviously incrementing I, and that is going to keep I. So that's just shorthand notation for I is equal to I plus 1. And that keeps I moving in that direction. And of course it starts there and it continues to move along. So what we'll do is we'll set this loop up. We will start at the beginning of the array and we'll process each element as we move through the array. So I will start off at 0, we'll do something with f.0, then I will increment and it will be at 1, and we'll do something with f1, and then I will increment and we'll do something with f3, and so on and so on and so on. When we get to f3, so when we're processing down here and we get to I equal to 3, we'll have a value of 67 in the array. So we'll find it at that point. And if we continue on, we'll find another value of 67 at this point. So for the moment we'll leave that, but just remember that there are two 67s in the array. Let's have a look at our loop first, and we'll construct a very simple template, and we'll use it to actually print out the array. And when we've got the array printed out, we'll use that same template then to search the array for the value that's stored in X. So going back over to our code window here, the first thing that we're going to do is declare the array. So let's declare the array. So we're going to say int, and it's an array, so we use our square brackets, f, and that's equal to, and we've got some fixed values in here, so we're using our bracket notation just to put some fixed values in. So 5, 3, 67 of course, 2, and another 67, 9, 10, 56, and the last value is 4. Okay, so we've declared our array. Let's declare our search key. So the search key, let's set up the search key. So the search key is going to be int x, and that's going to be equal to 67. Of course it could be equal to any value, but this is just an example. We're searching for 67. So the next thing that we're going to do is we're going to print the array. Okay, so we're going to print the array, but what I'm going to do is I'm going to write a method to print the array, because I think it would be far more beneficial to write a method to print the array, because we can use that method again rather than repeating code. So for the print array, I'm going to write a method, so we can use it again. Makes sense. Okay, so let's go and write a method to print the contents of the array. So we'll have public static void. It's not going to return anything, and I'm going to call it print array. Now it's going to need to take some parameters. It's going to need to take an array. We're going to pass the array over as a parameter or as an argument. So I'll say int and the brackets to signify an array, and I'll call the argument a. And in our print we're going to use our template. We're going to use our loop template down over here. So for I equal to 0, I less than the length of the array, I++, and we're going to process the array. So we'll use that template. So for int I equal to 0, I less than, now the argument that we've passed over here is a. Alright, so we have the integer array a as an argument here. So we're going to use, in our loop here, we're going to use a dot length. And then we're going to have I++. And we'll say system.out.printf, and I'm going to use $D for a number and put a space so we have the number spaced out, and then I'll say AI. So I'm processing the array. So the loop is going to give me a loop counter that starts at 0, continues through to the length of the array, and is incremented by 1 each time. So to access each element of the array, I simply say AI in the brackets. Now I'd like to maybe print a line before I print out the numbers and after I print out the numbers. So I'm just going to put a blank kind of system.out.println. And I'll put 2 down, put 1 before the loop and 1 after the loop. Okay, so now that we've got our method written, what we're going to do is, the first thing we're going to do is, let's test that out and print the array. So I'll just make a call to print array, and I'll pass over my array f. So the array that I'm dealing with in here is f in the main method. So I'm just going to pass over f as an argument to my print array function. And then later on we will search the array. So we'll say search array for key value x. Okay, let's just compile this and see that it works. And we see our array printed out here. So we now have a method that prints the array. So we can use this now as a template to write a method to search the array. So rather than put the code for the search and the print all within the main method, you can see I'm breaking the problem down into blocks. I've got a method to print the array, and now what I'm going to do is write a method to search the array, to do the linear search. So I'm just going to write a kind of skeleton method here. First of all, I'm going to say public, and this time it's going to be static, and I'm going to say boolean, because I want the search to return a boolean. It will return true if it finds the value, and it will return false if it doesn't. So static boolean, and I'll just call this linear search. And this method is actually going to take 2 arguments, or 2 parameters. The first parameter that I'm going to pass over will be very similar to the print. I'm going to pass over an array, and that's obviously going to be int with the brackets, and I'll call that argument or parameter a again. And the next parameter that I'm going to pass over, the second one, is going to be the key that I need to search for. So I'll say int, and I'll just say key. And that's all I'm going to do for the moment. I'm just going to leave the body of this method blank, because I want to talk about how we're going to actually do this. Okay, so back over to our little diagram here, and what we're going to do here is we're going to look at how we can perform a linear search. Now, to do the linear search, we're going to introduce another variable, and we're going to say that we're going to need a Boolean variable. So we're going to introduce a Boolean, and that Boolean is going to be called found. And found at the very beginning is going to start off as false. Okay, so when we initialize I to 0 and we start at the beginning of the array, when we go to process the array down here, effectively what we're going to do is just check each value in the array to see is it equal to x. So at the beginning of our loop, what we're going to do is we're going to say Boolean found equals false, and our loop will begin. And inside the loop we'll have an if statement. So we'll say if, and in this case the name of our array over here is f, so let's stick with that. So we'll say if f I is equal to x, then what we'll do is we'll say found will be equal to true. And we finish the loop. So inside the loop, all it's going to do is it's going to check to see if fi is equal to x, and if it is, it will set found equal to true. And remember that the Boolean variable found up here is going to start off at the beginning equal to false. So it will only ever change to true when we come across the value that we're looking for in the array. Now if we think about this for a second, what's going to happen is I will be equal to 0 to begin with, and f0 is 21, so that's not equal to 67, so found will still be false. And as I progresses, so as it moves through the array, so as I progresses, I is now at 1, and we'll say is f1 equal to 67? No, it's not. So we'll move on. Now I will be here. Is f2 equal to 67? No, it's not. Found will remain false. And then we'll get to f3, and we'll say is fi at this position equal to 67? Yes, it is. And in the if statement in our loop, found will now become equal to true. And we'll move on. And f4 is not equal to 67. But look, found still remains true. We don't change found. The only time found changes is when we find an fi that's equal to x. So found will remain true. Okay, and I will move on again. And actually we'll come across the second 67 at f5. Now what will happen here is we'll go back into the if statement, and fi will indeed equal x, and we'll set found equal to true again, even though it already is. So effectively we've kind of found the second occurrence of 67, and we'll continue on like this, processing the array, and of course that's not 67, we'll move on, and that's not 67, we'll move on, and so on all the way to the end of the array. Okay, so what we're going to do now is we're going to use the template that we constructed for printing the array, and we're going to basically just use that template, reuse that template, and put in an if statement to check to see if fi, or in this case over here, is equal to x. So let's go back to our code, and what we can do is we can actually copy the code from the print down into here, and remember we're also going to need our Boolean variable. So I'm going to say Boolean found, and I'm going to set that equal to false to begin with, and then I'm going to get rid of the system out, I don't need that, and then I'm going to put in my if. So I'm going to say if, and remember this is in a method, so the array argument that we passed in is called a. So I can say if a I is equal to, and we're not looking for x because remember we have this search key argument here that we're going to use, so we're going to pass over the value we're looking for, and that's stored in this key argument. So we say if AI is equal to key, then all I have to do is say found is equal to true. Okay, so this loop will set found equal to true when it comes across an AI that's equal to the key that we're looking for. Alright, are we finished? Well, no, not really, because the next thing that we need to do is remember this linear search method is going to return a boolean. So what do you think we need to return? Well, the outcome of the search is really going to be stored in found. So when the loop is finished, what we'll do is we'll return found, and that will pass back the result of the search through this boolean here. Okay, the next thing that we need to do is actually test this out. So let's put some comments in here. So this is our linear search method, and of course this is our print method. So I did the print first, and I used that as a template then to create the search. Couple of an extra argument here in the search method, but apart from that the loop is the same. I have an if statement and a boolean found, and of course the search is returning a value here through this boolean, and it does that when the loop ends we'll return the outcome of found. So let's test this out by calling the method from our main method. So what I'm going to do is I'm going to say if linear search, and I'm going to pass over my array f just like I did to the print, and I'm going to pass over the key that I'm looking for, the value that I'm looking for, so that's stored in x. So I'm going to pass over x. So I'm going to say if linear search searching f for x is equal to true, then I'll say system.out println x has been found. And then what I'll do is I'll say else system.out println x does not exist. And that is our linear search. So if I compile this now and run it, hopefully we have no errors. Okay, no errors. And let's run it and see what happens. Okay, so we get our array printed and we get the message x has been found. Okay, so which x has been found, or which occurrence of 67 has been found? Well, it doesn't really matter. It's in there. That's all that really matters. But really, it's kind of this one that has been found. Okay, so it's really kind of the last one, because remember we're going to process the entire array. We start at the beginning here and we keep on moving through the array all the way along, and even when we find the value we don't stop. We keep going and we keep going and we keep going, and so on until we get to the end of the array. So what about if we wanted to make this a little bit better? What about if we wanted to make it more efficient, and when we find the first one, just stop? If this was an array with 1,000,000 values in it and 67 occurred in the 4th position at index 3, Would we want to continue searching the array, the rest of the million values in the array, or would we just want to stop here? Chances are that we just want to stop. So we can make our search method a little bit more efficient by going and looking at the loop. So in our for loop down here, what we'll do is we just rub this one out and we'll make this a little bit better. So we're going to include something in the guard of the loop so that it makes this search a little bit more efficient. So what we can say is, we can say, actually let's do this in white. So we can say for, and it's the usual stuff at the beginning of the loop, so we can say for int I equal to 0. We're still going to start at the beginning, and then we can say I less than f dot length. That's kind of critically important. Okay, so we can say I less than f dot length and found, or actually let's do this a neater way. So we can say and not found. So the exclamation symbol there is the negation symbol in Java, and we can say not found I plus plus. So int I equal to 0, I less than the length of the array, and not found, which means as soon as found becomes true, this guard will be broken, because we're going to loop to the end of the array as long as it's not found. So to show how this works, what we can do is, if we go back to our LinearSearch method, when we say if AI is equal to key and we set found equal to true, what I'll do here just to prove a point is I'll put in a system out, kind of debugging the code just to show what's going on. So we'll say system out and we'll print out the index that we find the value at, and that's I. So we'll say found key at, and we'll output I. Okay, so we'll save that and compile and run again. Okay, so in our output down here we can see that we have our array printed out, and then it said found key at 3, and it finds the key again at 5. And if we go over to our little diagram over here, we can see yes, 67 is found at index 3, and it's also found at index 5. So if we only wanted to search until we found the first occurrence, this approach isn't going to work. It's going to keep searching and searching and searching and searching. So let's improve it by adding in this found bit into the guard of the loop, because the guard of the loop is what keeps the loop, or allows the loop to keep going. So in this guard, as long as found is equal to false, it will keep looping until the end of the array. But when found becomes true, then this will break and the loop will stop. So we'll only find the first occurrence. So in order to prove this, what we'll do is I'm going to copy my linear search method here. I'm going to make 2 linear searches. So I'll copy that and I'm going to put it in. I'm going to repeat it, linear search method, and I'm going to call this version 2. And I'm going to call the method again linear search. I'm going to call it linear search. Let's call it linear search v2. Okay, and I'm going to change the guard on the loop in version 2. So I'm going to say I, let's just bracket this off for clarity. Let's say I less than a.length and not found. So while I is less than the length of the array and not found, in other words, found will be false. So as long as found is false, we'll continue to loop. And again, we'll check if AI is equal to the key that we're looking for. We'll set found equal to true, and we'll print out where we found the key. This isn't necessary really, we're just putting this system out in here so we can see the index that we found the key at. Okay, and then down in my main method what I'll do is I'll repeat my if statement. So I'll do a little system out, system.out dot println linear search version 1, and we'll do the usual what we did before, check to see if linear search fx equal to true and do some system output. And I'm going to copy this entire block of code again and repeat it, except this time instead of calling linear search I'm going to call linear search v2. So I have linear search v2, pass over the array and the key that we're looking for, and so on. And we'll save that and compile, and let's run. Okay, so let's have a look at our output window. So we print the array, and this is linear search version 1. Oops, I made a little mistake there. Just in my output I'm going to change that to linear search version 2, and I'm going to save and compile again just to be absolutely clear. Okay, so we print the array, and this is linear search version 1. Okay, so it finds it, which is no surprise because we know it's there, but it finds the key at index 3 and it finds the key at index 5, and it says at the end X has been found. Now this is linear search version 2, and as we can see it says linear search version 2 found key at 3, and you'll notice it stops. It doesn't find the one at index 5 because the loop just stops. It loops until it finds the first 67, and then that's it. Found becomes equal to true, the guard on the loop is broken, and we finish looping, and we come out of the loop and we print X has been found. So this linear search that we've been looking at, it isn't a terribly efficient search. However, we can make it a little bit better by stopping when we have found the value, and we can do that by using our boolean variable in the guard of the loop, and we can search the entire length of the array, or when we find it we stop. By including the boolean in the guard of our loop we can do that. So we have 2 versions of our linear search. Version 2 is slightly more efficient, at least it will stop when it has found the value in the array. Version 1 isn't so efficient because it will continue looping through the array even though it has found the value that we're looking for.